Hi folks, we're going to take a look at number 62 from page 444. So here they tell us that the hypotenuse of a right triangle is 20 centimeters long and the sum of the lengths of the two legs is 28 centimeters, and they want us to find the length of each leg. All right, so let's draw ourselves a picture here. So we've got a right triangle. All right, and I know that the hypotenuse measures 20. Now, I don't know the individual legs, so let me give them names. Let's say I call them A and B. I know that the sum of A and B is equal to 28. All right, so clearly this is not enough information to solve for A and B. We know that if we've got two unknowns, we need two equations. So we're going to need to find a second equation, and obviously something that's going to involve the known piece of information, which is hypotenuse. So really the only thing that comes to mind, since there's no indication that we're interested in or given anything about the angles, we should work with Pythagoras since we have a right angle triangle. Okay, so we know that A plus B is equal to 28, but by Pythagoras, we also know that A squared plus B squared is equal to 20 squared. All right, so here's our second equation. Now, when you're working with a system of equations that involves, powers of 2 in one of the equations, it makes more sense to work with substitution. And we should be isolating a variable in this equation here. The last thing we want to do is bring in square roots if we don't have to. So I'll isolate B in this equation. So B is equal to 28 minus A. And now I'm going to substitute that into our second equation. So here we have A squared plus, wherever I see B, I can replace that by 28 minus A. Okay, and 20 squared is 400. And so now we've got a quadratic equation, so we can solve it, and we know that there's a possibility of having more than one answer. All right, so the procedure for solving a quadratic equation is to simplify both sides and then bring everything to one side, so we've got 0 on the other side. All right, so here I'm going to square this binomial. So here 28 squared, so I'm doing that in our heads. 28 squared is 784. So square the first, square the last. So we know we're going to have a plus A squared, and then twice the product of first and last. So 28 times negative A is negative 28 times 2 is 56. So minus 56A. Okay, and all that is equal to 400. All right, so now A squared plus A squared is 2A squared. Here we've got our minus 56A, and then here I'll bring the 400 to the other side, so 784 minus 400, that's going to be 384. All right, and to simplify things, since they're all divisible by 2, I'm going to divide both sides of the equation by 2. Okay, so if I divide this trinomial by 2, I'm going to be left with A squared minus 28A and 384. Let's just do it on our calculator just to be sure. Divided by 2 is 192 equals 0, since 0 divided by 2 is just 0. And so now here, I could try to look, since there's no coefficient here in front of the A squared, or the coefficient is 1, I could try to factor, but I think I'm just going to stick this into the quadratic formula, so I don't have to worry about thinking about what the factors of 192 are. Okay, so here we have negative B, so that's going to be 28 plus or minus square root of 28 squared, or B squared, minus 4 times A, which is 1, and C, which is 192, all over 2A. And since here A, I mean the coefficient of the square, so here that's just going to be 2. All right. So I always suggest that you simplify this portion first before you stick anything into your calculator. So here we have 28 plus or minus. So let's see what happens when we take 28 squared minus 4 times 1 times 192. And we've got 16. So the square root of 16 is just 4. So this will actually be nice integer answers over 2. And so here we have 28 plus 4 is 32 divided by 2 is 16. And our other possible answer, 28 minus 4 is 24 divided by 2, which is 12. And these are both valid answers since they're positive. So it could be there's two different triangles that give us these, that meet these conditions. So let's find the b values. So here we've got a is equal to 16. So in this case here, b would be 28 minus 16, and that would be 12. And I think I see what's going on here, because when I put a equals 12, and then b is going to be equal to 28 minus 12, which is 16. So in the end, we're getting the same measurements for these sides. Just in one scenario, the base here is the longer one and the height is the shorter one, or the base could be the shorter one and the height is the longer one. So in the end, we know that the lengths of the legs are 12 centimeters and 16 centimeters. All right. Okay, so let's recap this problem. So step one was to realize that we were looking for these two measurements, which we didn't know, so we gave them variable names. And then from there, we saw that one connection between those two sides was that they had to add up to 28. But since we're looking for two variables, we needed a second equation. And we used the fact that we were working with a right angle triangle to set up a Pythagorean equation. And then from there, we performed a substitution to get a quadratic equation in one variable, and we were able to solve. Okay, that's it for this one.